Welcome to another video. In my previous videos, I have shown how to install different versions of Proteus. In this video, we're going to learn how to design the PCB using Proteus Aries. So I will be using the latest version of Proteus Aries, which is Proteus 8.10 for this tutorial. To get maximum out of this video, please watch the video till the end and don't forget to subscribe our channel. So let us begin. So basically, there are two methods to design a PCB. The first method, in which you first create your schematic and then transfer your schematic into the Proteus Aries. The second method, which is comparatively difficult, is that you directly start in the PCB Aries to design your PCB. So I will explain the first method, which is the most easiest and the efficient one. That is, you start creating the schematic first according to your circuit diagram. So I hope you know how to work in the Proteus 8 interface. If you don't, please follow the video which is about the beginner's tutorial of how to use Proteus 8.9. So let's start by creating a schematic diagram. For the demonstration purpose, I am using a built-in example of Proteus. So in this example, all the components have been already placed and connected according to the circuit diagram. So for example, I need to make a connection between PIC 18F452 and IC U5. So if I have to connect pin 16 of PIC with pin 1 of U5, what I have to do, I will be using the terminals for the input, output, power and ground connections so that all the terminals appear in the PCB design in Proteus Aries. The connection can be made by two different methods. You can directly connect different components through the wire, or you can use the terminal. But remember, for ground and supply, you must use the power terminals in order to properly identify the trace in Proteus Aries. So let me demonstrate. First, I need the output. Go to the terminal mode tab, select output, place here and connect with pin 16. Label it as UD0. Similarly, just select input terminal, place it here and connect with pin 1 of U5. Remember that label the input pin exactly the same as you have already labeled the output pin, so that you tell the software that you made the connection between pin 16 and pin 1. So I will again name it as UD0. Similarly, you will make all the connection according to your circuit diagram. For the ground terminal, again go to the terminal mode, click ground, place here and connect with all the ground terminals in your circuit. And for supply, you need to select power, place it here and connect with all the power nodes in the schematic diagram. So what you have done, you have used 4 terminals which are input, output, power and ground, and use them to connect your circuit diagram. Next step is we have to transfer our circuit diagram into Proteus Aries. For this, we go to the PCB layout tab, click the PCB layout, and you can see that all the components that have been used in the schematic appear in the component list. Remember, you only select those components in the schematic diagram which have a PCB package model. Otherwise, those components will not appear in the Proteus Aries, or you have to create your own package for this component. Next step is you need to create the PCB board. For this, you need to draw a boundary according to the dimensions of your PCB board. Let's say that I am going to make a PCB of dimension 4 inches into 2 inches or 100 mm into 25 mm. For this, go to the technology and set grid snaps. Since I have to draw a dimension of 100 mm cross 50 mm, so I will select this F4 snap equal to 25 mm. What does it mean? It means that when I select snap 4 from view menu, each grid will be equal to 25 mm. Select the rectangle here and remember, select the board edge. Now each grid is equal to 25 mm, so 4 mm cross 2 mm, this will be my PCB board. Remember that the boundary of the PCB board will be represented by yellow lines in Proteus areas. If you want to see your board in the 3D visualizer, go to the 3D visualizer and you see that you have created the PCB board of dimension 4 inches by 2 inches. Now the another step is to auto place the components within the boundary of the PCB. For this, go to auto placer tab, select all the components you want to place within the boundary and click OK. And the software will automatically start placing all the components inside the boundary of the PCB. Okay. In the software, you can also place the component wherever you want. Click on the component, drag the component and place it at your desired location. Now I have finished placing all the components according to my desired requirement. So next thing is you need to auto route all the signals. Select this option, auto router. So what will this software do? It will automatically connect all the components with the trace size which you have mentioned in the design rule. Open the design rule. I am using 2-layer PCB, top copper and bottom copper. It depends on your design how much layers will you want to use in your PCB, and it depends on the complexity of the circuit. In the net class tab, go to the power net class. Here you can see that the trace for the power is 25 and wire for the power is V40, and both coppers will be used for the power. Similarly, for signaling, it will use a trace of smaller weight, which is T10, and it will also use both the top or the bottom copper for signaling. Click OK. You can change the dimensions of the trace or the conductor according to your requirement. Click OK. Now, after you have set the parameters in the design rule manager, click auto router. So you need to check this option, allow off grid routing, begin routing, and here you go. The software will start placing the trace and connecting the components with each other. So here you see that software has finished routing the traces and connect all the components with each other, and you can see here that there are no CRC or DRC errors. So this is what is required. Now you can also see in the 3D visualizer. Here you go. Now it's a beautiful site for any PCB designer. This is a 2-layer PCB. Okay, now if you want to create the zone, there are two options for the zone or the plane. The first is the zone for the ground and the other is zone for the positive supply. Normally, the designers used to create zone for the ground in order to avoid interloop interferences. For the zone creation, go to the zone mode. The pointer will change its shape. Select the area inside the boundary. So it will ask you which zone you want to create, top copper or bottom copper. I will select bottom copper for the ground, click OK, and here you go, the zone is created. Now finally, what we have to do, we have to create the Gerber file for this PCB. The Gerber files are used for the production by PCB production machinery. For this, go to the Output tab and click Generate Gerber or Epsilon files. So it will automatically select the pre-production check so that there will be no error. Now it will ask to make a folder and the destination where all these CAD/CAM files for the selected layers are placed. Check the desired layer for which the CAD/CAM files are required. Select the resolution and click OK. Now you see that in the thermo folder, all the CAD/CAM files for the selected layers have been created. So this is all for this video. I hope you like the video and you learn how to design PCB in Proteus Aries. So stay tuned and don't forget to subscribe our channel. Thank you for watching.